Hello everyone, for this tutorial video I like to explain factors in a capacitor that affect the exact amount of capacitance it will have. In particular, if we remember the previous tutorial video about how capacitors work in general, we should be able to guess that a capacitor with a larger plate area will be able to store more voltage than one with a smaller plate area because there is a larger field overall between the two plates. What might not be as immediately obvious is that the shorter the length of the material between the plates, the more capacitance. But an explanation of this is that when the distance is shorter, there is less insulating material overall, so there is less resistance to capacitance. And lastly, the capacitance depends on the exact material that is used as the insulator between the plates, called the dielectric. And like other electrical properties like resistivity, the dielectric constant must be judged on a case-by-case basis. There is no neat way to predict the exact number for it. And you will also hear the dielectric constant called permittivity, which should make sense if you know that permission means to get allowance to do something. So something with a greater permittivity literally has more permission for capacitance to occur. So in conclusion, for any capacitor you design, capacitance equals permittivity times area all over a distance. And so there are capacitors that have variable capacitances rather than specific capacitances, which work by letting you change the amount of plate overlap so that the cross-sectional area and distance changes, causing the overall capacitance to change. In my next tutorial video, I like to talk about how multiple capacitors in combination create a total capacitance that is different than the individual capacitors, almost exactly like how resistors work. But the twist here is that total capacitance works in reverse to total resistance, namely that the total capacitance is less in a series and more in parallel, whereas the opposite was true for resistors. And we will see explanations of why this is true in the next video. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.